This next strategy is factoring things that are in a quadratic form. So they aren't exactly a quadratic, but they look very similar. Okay. So this first example, we have x to the fourth plus 5x squared minus 6. Compare that to x squared plus 5x minus 6. Could we factor x squared plus 5x minus 6? So two things that multiply to a negative 6, but add to 5. Since we're multiplying to a negative, they have to be opposites, right? Opposites, not both of them plus, opposites. And what works? Well, this would be plus 6 minus 1, right? Well, on the left we have x to the fourth plus 5x squared minus 6. X to the fourth is an x squared squared. So here's two different ways to think about this. We have essentially a quadratic. We have x squared squared plus 5x squared minus 6. So we really do have something squared plus 5 times that something minus a constant. And it looks very similar to that other one, except instead of x's here, it's an x squared that's squared. So if we can make it look like that, then it fits the quadratic form. Or maybe what's an easier way to think about it is if this exponent is double that one, and this is a constant, then it's going to fit the quadratic form. Okay. So look for this one. If this one is double what we have here, it fits the quadratic form, and we can factor it like a quadratic. So this whole thing factors very similarly to what we had there, but instead of x and x, what gets us to x to the fourth? Well, we want x squared and x squared. And then when we multiply by the constant, that's going to get us terms that just have x squared. So it's the same as what we have over here on the right. What multiplies to a negative 6 and adds to 5? Well, that's a positive 6 and a negative 1. And then we can maybe sometimes go further. So sometimes we might get stuck there. But we have a difference of squares again. So x squared plus 6, that does not factor. X squared minus 1 would be x minus 1, x plus 1. So there's factoring with the quadratic form. It looks like a quadratic, but isn't quite exactly a quadratic. Moving on to the next example. Maybe we don't see a pattern here yet, but remember, what have we said is the first thing we should always look for? Greatest common factor. Okay, so is there a greatest common factor? Is there anything that goes into all three of those terms? 3x to the 12th plus 54x to the 7th plus 51x squared. 3x squared is in each of those terms. We can factor out a 3x squared, and that's going to give us x to the, take out 2 x's from x to the 12th, and that's x to the 10th. Remember that when we divide something out, we subtract. Okay. 54 divided by 3 is 18. And then if we take out x squared, that leaves us with x to the 5th. And 51 divided by 3 is 17. So x to the 10th plus 18, x to the 5th plus 17. Now this one fits the quadratic form, because again, we look for, is this one double that second one there? And it is. So we can factor it as if it were x squared plus 18x plus 17. So we multiply to a positive and add to a positive, so they're both x plus, except not x, it's going to be x to the 5th, x to the 5th plus. And this one's pretty easy because only things that multiply to 17 are 17 and 1. So we have 3x squared plus x to the 5th plus 17 times x to the 5th plus 1. Nothing else we can do with any of those terms. So 3x squared times x to the 5th plus 17 times x to the 5th plus 1. That is factored completely